Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here today to do a technical test of the Boyuurange Reisong A10 A12 amplifier. This is the A12 that has the 12AX7 tubes. The earlier version, the A10, had some more obscure Russian tubes that were very similar but had a different pinout. And they changed the design to these 12AX7s so it was easier for people to tube roll in these amps. So I'm going to assume that the performance is very similar because I don't think much has changed besides that. This is going to be a technical test today. We are not doing a subjective review of the sonic loveliness. You're not going to hear phrases like chocolatey mid-range, etc. We are purely hooking this thing up to analog scope with a signal generator. Then we're going to connect it to the Analog Discovery 2 with the audio analyzer suite and be looking at the THD versus power. We're going to be looking at the frequency response, and we're also going to be looking at the THD versus frequency. I know there's been a lot of subjective reviews of this amp both in forums and on YouTube. That's not what we're doing. We're going to show this thing warts and all, and then hopefully if it does fail these tests, that we're going to try to discover what the problems are and what, if anything, can be done to resolve them. Just like we did with the A50. Again, that was another popular amp that got rave reviews from a lot of these influencers on YouTube, but in my testing, it was kind of garbage. And not sure what this is going to be. I am a little concerned. I've done some preliminary voltage tests, and let me pull these up. So in the preliminary voltage test, I'm seeing 334 volts on the plate, which is pretty low from my experience. It's also got 22.5 volts on the cathode. So you subtract that from the 334 and you end up with 312 or so across the tube. And in my experience, to get good performance out of an EL34, you need to be approaching or over 400 volts across the tube. So I'm going to be shocked if this thing really puts out its rated 6 watts of power. And I've also found that these lower voltages tend to increase the distortion numbers. So we'll see that when we run the tests on it. The other thing that's really odd is the way the rectifier tube is wired up. The power transformer doesn't have a center tap, and while I'm not going to go deep into the technical details of that, the rectifier tube, while it is in the circuit, is more for show than actual sound qualities. And I'm not going to dig into the rest of the schematic right now. I'm going to try to keep this more high level and about the actual test. The next video, I'll do a deep dive into the schematic, start looking at where there may or may not be problem points and how we can fix it. My goal is to not have to replace any of the iron if we can keep from doing that, because that's when it gets to be a pain trying to find iron that'll fit in the footprint that is the same style. And like with the A50, I think at that point you're starting to invest more money in the amplifier than is worth, and it's easier just to build one from scratch. Again, this is a $500 price point amp pre-built from Amazon, and that's approximately the price that all the parts would cost to DIY build a 6SQ7 EL34 amp that we covered in another video that I'll put in the description. So without further ado, let's jump into hooking this thing up to the scope and see what the preliminary findings are. Okay, the first test we're going to run this amp through is hooked up to my analog Tektronix scope with a analog audio generator. We're putting in a 1K signal and we're supplying the amp with a 3-volt peak-to-peak signal, which I feel is a good representation of the music volume output swing you would get out of something like a CD deck or a DAC. We got it on 1 volt per division, so we're going to flip this back to 2 volts just to kind of get this up out of our way a little bit. And we're going to turn the volume up and see what we get. Okay guys, I don't know if you're seeing what I'm seeing, but this is some monster distortion. And we're not even at 1 watt yet. See how fat this top section is? And how pointed this one is? And let me try to overlay these on top of each other. Let me switch this back to 1 volt. And pull this down. And I'm going to go ahead and turn the volume up. Well, clipping. We haven't even gotten... Wow, this is a hot mess. Let me... Guys, this is painful to look at. I'm going to... Okay, this upper one is the in signal. So I'm going to turn the volume down to that point. And even there, the signals aren't matching. So like what's going into the amp is not what's coming out. And that's not even 10 volts peak to peak, which is less than 1 watt. And when we start turning this thing up, right there it starts clipping. And so we're getting less than 10 volts peak to peak into an 8 ohm load out of this thing before it starts clipping. Wow, that is really not good. So before we waste a lot of time on this, I mean you start turning it up and there is just super hard clipping on both sides. And it's incapable, and I'll do the math and put this in the video, it's incapable of making power past this point, which is 15 volts peak to peak. Because the more you turn it up, just the more it clips. And the harder it clips. It starts just turning it into a square wave. So whatever they advertise this amp at any distortion level, it's not making any power past that. So let's take a look at what the square wave looks like. So again, this lower one is the amplifier out and this is the in. So we're going to switch this to a square wave, put it back at 1 volt. We're going to turn this back up to we're getting 3 volts peak to peak on our square wave. Shrink that back down a little bit, get it out of our way. And then let's turn the volume up. And massive ringing. I mean, that's 3/4 volume. That's 5/8. I mean, it doesn't keep ringing all the way across, and look how this one's overshooting and that's undershooting. That's pretty ugly. And as we turn the frequency up, it just gets even worse. It's ringing 3/4 of the way across the top of the waveform. This is some pretty ugly stuff, guys. Even at low volume levels, there's a ton of ringing. So let's, just for fun, let's see if we can see what the low frequency looks like. And at low frequencies, we're seeing all kinds of wonky looking square wave reproduction too. So this amp clearly has got some issues and is bordering on having stability problems. I mean, when I look up at that amount of overshoot, I've never seen that in any amp I've built. So the last thing I want to do is I want to see if what we're seeing is at the driver tube or if it's, in the driver circuit. So let's put this back at 3 volts peak to peak, and I'm going to turn the amp on its side and move the second channel probe to the grid of the output tube and see what kind of signal we're seeing there. Okay, this is the scope hooked up to the grid of the output tube, which is on the other side of the coupling capacitor that's hooked to the driver. So this is going to be showing us what the signal looks like going into the output tube. Let's go ahead and flip this back to 2 volts. And okay, signal's inverted, so I'm going to hit this inversion thing just so we can directly compare them. And now we're seeing the same signal coming out that's going in. So the distortion we're seeing is not in the driver circuit. Whatever we have going on is either something to do with the output tube and the way it's wired, or there's a problem with the output transformer. And from the voltages that I saw measuring the internal voltages, I think we've got some wiring problems in the way that the output tube's set up. So let's go ahead and see what kind of drive we're going to get out of this driver tube into the grid of the EL34. We're going to put it on our 10x multiplier, and then we're going to switch this one over to 20 volts per division, and let's see what we get out of it before we start seeing clipping. Okay, there's our clipping right there. So, right there. Looks like 44 volts of swing into the grid of the output tube, which should be enough to drive an EL34. Now, I would like to get rid of this little bit of clipping down here at the bottom, but it doesn't start doing that till about 7/8 on the scale. And we were seeing distortion on the output tube even at half volume. So the driver is not where the problem lies, although we could make some improvements here and maybe get some more drive out of it, or input sensitivity. But for now, I want to focus on the output tube. So the next test I want to do is I want to hook this up to the Analog Discovery 2 using the Audio Analyzer Suite software and see if it verifies what we're seeing on the analog scope. Well, I've got the amp connected up to the Analog Discovery 2, and it's been warming up for about 5 minutes. This is the test that I'm really excited about. In the description, I'll link a video that goes over this Audio Analyzer Suite and the Analog Discovery 2 to show you how this works. I do want to preface this with, this is not laboratory grade equipment, but it does provide a fairly accurate measurement, especially when you're comparing one amp to another, about what we're getting out of this amplifier. I've tested a dozen different amplifiers with the software suite, and the results that it shows equates to what I'm hearing when I'm listening to the amplifier. So without further ado, we're going to do a THD plus noise pull on this amplifier and see what we get with it set to 8 ohms impedance with an 8 ohm dummy load with the equipment hooked across the outputs, and see what kind of readings we get. And here we go. And wow. It never goes below 1%. Guys, I'm speechless. I mean, if we look at these measurements, people say, well, where does it make power at 1% distortion like is advertised? Makes 0.015 watts. If we look at what is the distortion number at 1 watt, depending on which channel, it's between 6 and 6.5%. And that's not even a watt, that's 0.9 watts. It's 6.5 to 7% at 1.1 watts. And the audio analyzer suite only allows up to 10% distortion, and it never hits 2 watts. Well, there it hits 2 watts at 10.93%, and then the program shuts off. This is the worst measuring piece of equipment that I've ever hooked up to this hardware. So let's try just the THD, and we'll ignore the extraneous noise that the amplifier creates and see what just the harmonic distortion reading is. Hey, we were able to get below 1%, and it goes past 1% at less than, let's see what this is. It crosses over 1% at 0.039 watts. Wow. I mean, it's not even making a tenth of a watt when it goes past 1% distortion. And at 1 watt, depending on exactly where you put this cursor, it's making 5% distortion at 1 watt. And it's not capable, there we go, it's making 2.3 watts at 10% distortion. So this amp is advertised as having less than 1% THD, which by this measurement, you're not even getting 0.05 watts at 1%, and 6 watts, which this thing's clearly not capable of making. We saw that both on the analog scope and on this analog Discovery 2 readings. I'm just stunned. I'm literally speechless looking at this. So let's move on. I mean, it's almost pointless to even look past this, but I'm going to go ahead and do a THD versus frequency, and we're not going to even measure the noise. We're just going to measure the THD. And I'm going to start this test and then fast forward to the end, and we can scroll back and forth and kind of show you what the spectrum looks like and what we're seeing here. But I'm not expecting anything really positive out of this. We're checking this at 0.8 watts, which is a reasonable figure to be checking any amplifier that we're going to be hooking speakers up to. And we're probably not going to see anything under 4% distortion. Okay, let's take a look at some of this. We're at 1K, and there's 4.5 to 5% distortion. And again, this is 0.8 watts we're measuring this at. I mean, it only gets below 4% distortion when you get up, close to 10K. And I don't think it never goes below 3%. And, I'm not shocked to see 10% distortion down here on the bottom end, especially with, probably not super high quality output transformers. I mean, that doesn't disturb me, but by this range right in here, it should be around 1% at this low a power output level, and we're clearly not seeing that. So last thing we want to do is we're going to do a frequency response range, and we're going to do this at 0.5 volts RMS level, which is what I measure most of the amps that I test at. And not unexpected, the frequency response doesn't flatten out until 200 hertz, and it stays flat to, let's be generous here, say 5K. So from 200 hertz to 5K, it's flat. It starts rolling off. By 10K, we're down to 1.2 dBs, and 20K, it's down 3 dBs. And same on the low end, we're down 2.5 dBs at 20 hertz, and even at a what I think is a reasonable expectation of an amp like this at 40 hertz, which is what most bookshelf speakers would be at, it's down over a decibel. This is not good either. It can't have a very good bass response. And again, there's not a lot of music when you get up over 10K, but there's quite a bit between 6 and 10K, and it's rolling off pretty hard there. I'm just stunned. I mean, I was expecting, seeing all the online reviews, and when I look at the forum threads and people raving about what a great sounding amplifier this is, and I look at these measurements, I just have to assume maybe this is their first tube amplifier, or maybe their first hi-fi amplifier, and they're used to listening to computer speakers, or I know I keep bumbling along. I'm just speechless. So the measurements speak for themselves. And let's go back to this screen here. Here's the THD versus power. And then here's the THD versus power on my 6SQ7 EL34 amp. And you can see the difference. And I thought that amp had pretty high total harmonic distortion, given that we were using 1950 vintage AM radio tubes for a driver. And this amp's using modern 12AX7 driver tubes with the same EL34 output tubes. And just so you know, I did try some Gold Lion new issue 12AX7 tubes that we ran in that preamp that measured fantastic, and it didn't make any difference. And I did try the EL34 L tubes out of my 6SQ7 amp, and it improved it about 0.5% of THD, which if we were down at the 1% reading, I might consider that a big improvement. But when we're at, 10% distortion at 2 watts, or was that 9% distortion at 2 watts, 0.5% of distortion isn't fixing the problem. So tube rolling isn't the issue here. This amp has some serious design flaws. So I'm going to end this segment and roll into the final comments. Well, guys, I'm not sure if disappointed is a strong enough term for what I saw with the technical test of this amplifier. I know these tests that I run are audible from what I see on the screen, because I've tested enough amplifiers and then listened to them to know that this much distortion is not going to sound good. And that kind of frequency response is not going to sound good. It's going to be clearly audible. I was hoping that the A50 was an anomaly in this series, that somehow that trying to meet the price point with a 300B was just too difficult, because I found it hard to build a 300B amp for under $1,000 for just the parts. And so from seeing all of the forum posts and the YouTube videos about how awesome this little EL34 amp is, and knocked it out of the park for the $500 price point, guys, it's not. This thing's got, again, some kind of serious design flaw to only be able to put out 2 watts of power, and that it's at 10% distortion doing that, that it has a hard time getting under 1% distortion at even headphone listening levels. And so, out of the box, I can't recommend you buy this amplifier. There has to be better quality, better sounding units at this price point, and this just isn't a good value. At this point, though, I don't know what the problem is. And it could be that a couple of resistor changes or a little few changes to the circuit, wake this thing up and fix this problem, sort of like we did with the Noob Sound 6P1 amp. That couple of resistor changes and modifying the circuit a little bit for $10 worth of parts, turned it around and made that a great sounding amp. But at this point, my modifications done to that Noob Sound 6P1 blow this amp out of the water. And that's just not right. So anyway, I'm not going to go on and on about this, and I'm sure this is going to be a controversial video, probably going to get some negative comments about, why are you bashing this amp, it sounds great and all that. I'm sorry, the numbers speak for themselves. I'm not injecting any kind of bias. I really hoped this thing would sound great. I love EL34 tubes. I love 12AX7 tubes. They can sound fantastic. And if I didn't say so earlier in the video, I did swap some Gold Lion new issue 12AX7 tubes, which are well known for being great sounding tubes. That didn't make any difference worth talking about. And then I swapped these PS Vane EL34s for some JJ EL34Ls, which again, everybody says they're good sounding tubes. I know they're good sounding tubes. That's what's in my 6SQ7 EL34 amp. And between the two of these, the tube swap made maybe 0.5% of distortion difference, which when you're talking about an amp that is 4 and 5, 6% distortion, 0.5% distortion isn't going to be audible. So that's not going to fix the problem. The way the power supply is wired, this rectifier tube could not have much effect, if any. But we will see. We're going to play around with the power supply, the rectifiers, how the screen voltages are set up, all that stuff, and trying to fix this amplifier with as few parts as possible. So please stay tuned. If you like the video, you like the series, please subscribe. Please like the video. And we'll be back soon for more A12 fun. Have a great day.